All right, hello everyone, this is Mr. Flores. Today we are going to continue our conversation about transformations in Unit 8. Today we're going to talk about 8.3, rotations. All right, your homework tonight will be worksheet 8.3, so you'll get that passed out to you after the notes today. So section 8.3 will be due next time for homework. All right, let's start today with our vocabulary. So if we start on the front page, we have our rotation. We can also call that a turn. So rotation is a transformation that rotates an image around a given point called the center of rotation. So here I have my center of rotation. Okay, the positive number of degrees x that a figure rotates is the angle of rotation. So if you take a look here, I have my point of rotation and I want to move this up x many degrees. And so here is my angle of rotation, x many degrees. Give you guys just a moment, make sure you have that filled in. Alright, so if we turn now to 8.3 on the inside of our notes, we have a major key concept. So just like we had yesterday, or excuse me, the last time you were in class, for 8.2 talking about reflections, we have similar definitions and rules for 8.3 rotations. And so if we want to rotate a point or a figure, we need to realize that rotations preserve distance. So if I am rotating a segment, so like I have here from VU to V prime U prime, if I'm going to rotate that x many degrees up, the distance of that segment should still stay the same. Same can be said about angle measures, right? When we rotate, all our angles will stay the same number of degrees. And so what happens is a rotation is following the definition of a rigid motion. So again, that is a rigid motion that preserves distance and angle measures. A rotation is a rigid motion. And along with this, we also had the idea that our pre-image to our image is one-to-one. So every point gets mapped onto one and only one corresponding point. So the image gets mapped onto one and only one new image. We also have some new notation. So when we talked about reflections, we used an uppercase r. So when we talk about rotations, we're going to use a lowercase r. So we see here that lowercase r is going to be rotated x many degrees. And then we're going to do this in the q direction. And we'll talk about what that means in just a moment. And in parentheses, we see here that we're going to be rotating the triangle UVW x many degrees. Now, when we talk about the q direction, what we're talking about right here, q, is we're saying that we're always going to be moving counterclockwise. And so that's what that little q means. So unless it says it specifically in the notes or in your homework or on the test, assume all our rotations to be happening counterclockwise. And if you're not quite sure which direction counterclockwise is, remember that moves in this direction going that way. Okay, so this is counterclockwise. So for example, if we take a look, say I have my focus point, right, my point right here, and I want to rotate this segment, let's say 90 degrees. So I'm going to take my point A, and I'm going to rotate that 90 degrees and put it right there, A prime. I'm going to do the same thing here with my point B. I'm going to rotate that 90 degrees, and I'll put it there, B prime. And now we see we have this segment from A prime to B prime. And so if we just take each point one at a time and rotate it, essentially we're rotating the entire segment, A prime, B prime. All right, let's take a look at some examples that we're going to come across in our notes and on the homework and on the test. Okay, so before we begin looking at some of the example problems, let's take a look at our coordinate notation and rules for the 4 types of rotations we're going to be doing in this section. Okay, so the first thing we need to notice here is that in my top left-hand corner, I have lowercase r, and then in parentheses it says 90 degrees, comma, O. And so what we're saying here is, again, that lowercase r means to rotate. So we're going to rotate 90 degrees counterclockwise about the origin. So here is my origin, right, the very center point of my xy coordinate system, and I want to rotate 90 degrees counterclockwise about my origin. And so the rule for that is if I take my point x comma y, and I take my number that's in the x position, I'm going to switch it and put it in my y position. Okay, and I'm going to do the same thing for y. The number that's sitting here as my y coordinate, I'm going to switch its position, and it's going to move to the x coordinate. Now the last thing we want to do here is you'll notice that there's this negative sitting in front of my new y. Well, what we're going to do is after we switch the position of the coordinate, we're going to multiply that front coordinate by -1. So if you take a look at my example, my pre-image, my point G, is placed at 2, 3. And if I want to rotate that 90 degrees, I'm going to switch their position. So 2, 3 will become 3, 2. And then I want to take that front number and multiply it by -1. So 3 times -1 will give me -3. And so we can see here, by graphing our original point and then graphing the image after we rotate it 90 degrees, if I draw these little dotted lines to the origin, we actually see we make a 90-degree angle right here at the bottom. And so again, that rule, and this is not something you have to necessarily memorize and put to memory, but if we're given the rule, we should be able to read this and be able to make sense of it and make sure that I'm sending my point x, y, and I'm switching their locations and then multiplying that front number by -1. If I take a look over here at the top right-hand corner, I have a similar rule for rotating 180 degrees around the origin. Remember, 180 degrees is a straight angle, or it makes a straight line. So if you notice that from point to point, we end up with a straight line. Now the rule for this 180-degree rotation is a little more straightforward. There's no switching involved. So if you notice, my x comma y is still in the same order, x comma y, but now you should notice that not just the front number, but both the front and the back number in my coordinates are now being multiplied by -1. And so here, if I take a look at my original point, the pre-image G, which is still sitting at 2, 3, if I want to rotate it 180 degrees, I'm going to follow my rule here, which says I'm going to take my point and multiply both the front and back number by -1. So 2 times -1 will give me -2. 3 times -1 will give me -3, and I now have my new point here at -2, 3. And again, once we plot that point, we can see that it forms this straight 180-degree angle. Next, if we take a look at the bottom left-hand corner, we have the rule for rotating 270 degrees. And so we're going to rotate 270 degrees around the origin. And so here is the rule for that. Again, this is similar to our 90-degree rotation. I'm still going to switch my x and y coordinates. So if you take a look, our x and y coordinates, x will be moved into the back position, y will be moved into the front position. But now if I want to rotate 270, instead of multiplying -1 by the front, I'll multiply -1 by the back number. And so here, my original point G at 2, 3, those coordinates will switch places, and so instead of 2, 3, I now have 3, 2, and then lastly I want to multiply that back number by -1, so 2 times -1 will give me -2. And when I plot that point 3, -2, you'll see that it takes me 270 degrees counterclockwise. Now, also make note that if you take the 360 degrees that makes the entire circle and subtract 270, we actually are left with a 90-degree angle. So what we're doing here when we rotate 270 degrees counterclockwise, we could also argue that that's the same as rotating 90 degrees clockwise, and if we go into this other direction, right? But for our rules and everything we're going to follow, like we mentioned earlier in the notes, we always assume that we're rotating counterclockwise. So when you see 270 degrees, we want to rotate counterclockwise. Lastly, we have our rule for rotating 360 degrees. So if we want to rotate 360 degrees, we should realize that that 360 degrees is actually going to take us right back to where we started from, because 360 degrees is going to give us the entire circle. And so here, I rotate 360 degrees, and I land exactly back onto the spot I started with. And so our point G, which is at 2, 3, will actually rotate and then come back to the same position at 2, 3. So our rule here, the rule that goes for a rotation of 360 degrees, is going to be XY gets sent to its original spot, X, Y. All right, problem number 1. Again, if we read the notation, lowercase r tells us that we're rotating 90 degrees about the origin, this segment AB. Again, I know it's a segment because if I look at the top of the letters AB, I have the notation for segments. So I'm rotating just the segment AB, and I want to rotate it 90 degrees going counterclockwise. The first method we can use is graphing method. We saw that earlier in the definition section, and what we can do is we can draw these little triangles where the slope is from the point to the origin, since that is the measure I want to go from is 90 degrees about the origin. I'll attach a line from A to the origin, and I can take that triangle, that right triangle I make, and I can throw it 90 degrees counterclockwise, and then now I see that the end of my slope of this hypotenuse will be where my new point is, A prime. The same can be done with B. I can make a line from B all the way to the origin and rotate that right triangle 90 degrees. Doing so puts my new segment B prime, which you see here in green. And if I connect B prime and A prime, I get back the new figure, which I have in red now, our final answer, which is the segment, or the image, A prime, B prime. The segment A prime, B prime. But why are we going to go through all that hard work when we just talked about some rules that will take us straight to the answer, right? We have a mapping coordinate rule that will take us from the segment AB to its image, A prime, B prime, by just following our rule for 90-degree rotations. And so if I take every point, so the point A, and I take the point B, and I apply my rotation rule, it will tell me the exact coordinates where A prime and B prime must lay. So let's first take a look at my point A. My original point A is located at -2, +3. So if I go over -2, up 3, there is my original point, point A. The first thing I want to do with this rule, again, is we notice that X, Y is going to change its order. And so the first thing I want to do is change the order from -2, 3 to 3, -2. But then again, we also have the next part which says I want to take that front number and I want to multiply it by -1. So notice this negative sitting up front, I'm going to multiply 3 by -1. And so my final answer is that A prime will exist at -3, -2. And if we take a look back at where our right triangle landed when we moved that 90 degrees, I go over -1, -2, -3, and then down 1, down 2. And so again, that is my point, -3, -2. The same thing can be done with point B, which is located at the spot 6, 6. So if we go to the right 6, and if we go up 6, we find our spot here at point B. And again, I'll switch the position. Now, by coincidence, 6 and 6 are the same number, so when I switch their positions, it doesn't look like much has changed. Okay, but the next part of the rule still says we have to multiply the front number by -1. So now I'm going to multiply the front number by -1, and I get the point B prime should be at -6, 6. And if we take a look here, if I go over -6, up 6, I get that same point B prime, and again, here is my new segment. It still sits in the exact same spot. For what we're going to do today, I am going to recommend that we stick to the coordinate method. It's much easier to use your rules. It also reinforces these ideas that we started on Monday, talking about the rules for translations, and what we were talking about last time in class are rules for reflections, right? We can always fall back on our coordinate method to take us straight to the answer. Problem number 3. I now want to take my triangle HFK, So I have this entire triangle from H to F to K, and I want to rotate that triangle 90 degrees counterclockwise about the origin. So again, using my coordinate method and my rule for 90-degree rotations, which says send x, y to negative y, comma, x, we want to map each point onto our new image. For point F, I started off with the point at negative 3, 5, so if I go over 1, 2, 3 in the negative direction and up 5 in the positive y direction, I land at point F, and I want to translate, or let me rephrase that, I want to rotate that point 90 degrees. And so I'm going to apply my rule, which says switch their order. So negative 3, 5 becomes 5, negative 3. And then the last part here again is to multiply by negative 1. And so I get F prime is at the point negative 5, negative 3. And so I can plot that point down here. I go over negative 5, and then I go down 3, and I end up at my point F prime. For H, we know that this point is at negative 4, 3. So 1, 2, 3, 4 in the negative direction, up 3, there's my point H prime. Again, I want to switch the position of their coordinates, so negative 4, 3 becomes 3, negative 4. And lastly, I want to multiply by negative 1 in that front coordinate. So I get H prime exists at negative 3, negative 4. So if I go over negative 3, down 4, I have my point here at H prime. And very last, we can do the exact same thing for point K. Again, notice that point K exists at 1, 1. So here's my point K. And like we saw in some of the examples before, when I take 1, 1, by coincidence, they're the same number, so I am going to just switch their order. It still looks like 1, 1, but our last step is to multiply by a negative 1 in the front coordinate. So I get my final point K prime is going to be at negative 1, comma 1. So here I'm going to go left 1, up 1, and that rotates 90 degrees that way. Okay, and then my last step is I want to connect my dots and draw my new figure. And so now I know my image of this 90 degree rotation will be at the triangle H prime, F prime, K prime. 90 degree rotation. Problem number 4. Another 90 degree rotation, this time with a quadrilateral. So I have the quadrilateral HNGU, so from H to N, from G to U, and I want to rotate this 90 degrees about the origin. Again, I'm going to use my coordinate method and my rule for 90 degree rotations. In fact, we've done this a couple times. Why don't you take a moment and allow yourself to try and rotate all 4 of these points, starting with H being at 1, negative 1, rotate these 90 degrees. Alright, let's check our work for point H. I switch the position of the coordinates and multiply the front number by negative 1. And so here's my front number. Negative 1 times negative 1, 2 negatives will give me back a positive. And so my new point H prime exists at 1, 1. By coincidence again, we notice that that lands on the point N, but that's still where my new point H prime exists, so I'm going to label it H prime here. For my point N, which started at 1, 1, I'm going to, again, switch their positions and multiply the front number by negative. And so positive 1 times negative 1 will give me negative 1. And so my new point N prime will be at the spot negative 1, positive 1, so that gets moved right here, N prime. For G, my point is at 5, negative 1, so I go over 5 to the right, down 1. There's my point G. I'm going to switch the coordinates to be negative 1, comma 5, but again, a negative times a negative will give me a positive, and so my new coordinate for G prime will exist up here at 1, comma 5. And so we see that's been rotated 90 degrees upwards, or counterclockwise. And lastly, we have point U, which is located at 4, negative 5, so if I go over 4, down 5, again, I switch the coordinates, multiply the front number here, negative 5, by negative 1, and I get U prime exists at 5, 4. So 5, comma 4. Over 5, up 4. Connecting those two, or excuse me, connecting those 4 dots, I get my new figure, my new quadrilateral, H prime, N prime, G prime, U prime. Notice that all the angle measures stay the same. And so if I take a look at the angle at vertex N, so this angle N right here, that will still be corresponding and congruent to our angle here at vertex N prime. Remember, corresponding points to corresponding figures will give us corresponding angles. Those corresponding angles will be congruent. Number 5. Number 5, we're now rotating, we see here, 180 degrees about the origin, and we're going to take our triangle KBW. So from KB to W, we want to rotate this 180 degrees, so it looks like we're sitting here in the second quadrant, which means we want to rotate down here to the third quadrant, quadrant 3. Again, we're going to use coordinate method, and the rule for coordinate method says that I'm going to send my point xy, and I'm going to multiply the x by -1, I'm going to multiply the y by -1. So nothing's being switched, but we're definitely changing things up by multiplying -1. So again, this is our rule for 180 degree rotations counterclockwise. So I'm going to start with my first point K, which exists at -2, +3. I'm going to multiply both coordinates by a -1, so -2 times -1 is +2. 3 times -1 is -3. So in essence, what's happening here is we're switching signs. Anytime we multiply by a negative, we know we're switching signs. Since both are being multiplied by a negative, everything switches signs. So what was once negative is now positive. What was positive is now negative. The same can be done for point B and point W. So I multiply each one by -1, and on point B prime I get it 1, -2. And I multiply W by -1, and I get my point at 3, 0. Now again, we should start making some connections. 180 degrees is a straight angle, or a straight line. So going from W all the way to W prime, notice we make a straight line. And the same can be said about KW, K to K prime, and B to B prime. And so now we say our figure has been rotated 180 degrees counterclockwise. Number 6, I'm taking this quadrilateral. It looks like a kite. I'm taking this quadrilateral and I'm going to be rotating this 180 degrees around the origin. And so N, J, S, E, so from N to J, S to E, and all the way back. We're going to use our rule, which again says multiply the x and the y by a -1, changing the sign of every coordinate. And so for my point N, which exists at 2, -1, multiplying everything by a -1, I get back the point N prime, which exists at -2, 1. My point J, which exists at 2, 0, I'm going to multiply everything there by -1, and I get my point J prime, which exists at -2, 0, right there on the x-axis. My point S, which is existing at 4, 0, I'm going to multiply that by -1, and I get -4, 0. And my final point E, which exists at 5, -4, I multiply everything by -1, and I get -5, +4 up top over here in the second quadrant. And so I connect all my lines, and I get the similar, almost the same looking shape. In fact, it is the same shape, it's the same size, it's just now in its new position, rotated 180 degrees counterclockwise. So going from here all the way up to here. Number 7, problem number 7. Here I'm rotating triangle BPM, so from BP to M, I'm going to rotate this triangle 270 degrees, so 270 degrees about the origin. And so we had a rule for that in our coordinate method. We are going to use the rule that says my point XY will be mapped onto my point Y, -x. So here again, like we saw with 90 degrees, my first step will be to switch my coordinates. So what was in the X position is now in the Y position. What's in the Y position is now in the X position. And then now I'm going to multiply that back number, that back coordinate, by -1. So let's take a look. Point B exists at the spot +3, -3. So here's my point B. I'm going to switch their coordinates. So now instead of 3, -3, I've got -3, +3. So again, those coordinates switch. I'm going to multiply my back coordinate by -1. And so my final image of the point B will be at the spot -3, -3. And so that takes me 270 degrees around the origin. My point P, which exists here at -1, -3, again, I'm going to switch the order of those points. So now I'm at -3, -1, multiplying the back coordinate, multiplying my back coordinate by -1, I get the point P is located at -3, 1. -3, 1. My last point M, which is located over 4, down 1, so at the point 4, -1, I switch the position of their coordinates, multiply that 4 by a -1. There's a typo here. This should just be -1. Let me fix that right now. This should just be a -1. -4, which puts me here at -1, -4, and we connect our final triangle, and that figure is here at its image, B prime, P prime, M prime. Okay, problem number 9. So if you take a look, problem number 9 is a little different than the last couple problems. For example, if you notice here, we are rotating the triangle NYC 90 degrees counterclockwise, but we're going to do it fixed around the point 1, 1. And so if you notice here, our point 1, 1 is no longer sitting at the origin, right? Our focal point is sitting right here. And so what we want to do is we want to come up with a process to still rotate this triangle 90 degrees, but in fact do it focused around a different point than the origin. So the process is going to begin by taking our focal point coordinates, so 1, 1, right, because that's the point we want to turn around, right, we want to rotate around. I'm going to take that point 1, 1 and subtract that point from each point on the vertices of my triangle. So here for my triangle NYC, I'm going to take away 1, 1 from each coordinate. So I got to go and count over, so my point N is over 2, up 2. My point Y is over 5, up 3. And my point C is over 5, down 1. And so here I have my coordinates for my 3 vertices. And like I said, we're going to subtract each vertice, each coordinate of the point, by the coordinate of our rotation point. And so here I'm just going to do this like we would do subtraction back in elementary school, just subtract straight down. And so 2 minus 1 and 2 minus 1 will give me 1, 1. 5 minus 1 will give me 4. 3 minus 1 will give me 2. 5 minus 1 will give me 4. -1 minus another 1 will give me -2. And so here, if we plot our new coordinates, we see that our triangle is actually shifted down 1, left 1, so it's actually kind of fixed around the origin again. And so what we're doing is, since we have this method for rotating around the origin, we're kind of forcing ourselves to start there, and we're going to fix it by putting it back up that unit using the coordinates once again. So I want to, now that I have my triangle shifted down towards the origin, I'm going to use my rule for a 90-degree rotation, which we saw earlier was just simply switch the positions of the x and y, multiply the front number by -1. So I'll do that for each point. So again, I take my point n1, or excuse me, n, which is at 1, 1. I switch their coordinates and then multiply the first by a negative, giving me -1, 1. Same here for y. I'm going to go ahead and switch their coordinates from 4, 2 to 2, 4 and multiply that front one by a negative. In C, I want you guys to notice that when we switch our coordinates, alright, I go from 4, -2 to 2, 4. And so what happens is when we switch positions, the 2 moves up front, but again, we need to multiply by a negative. And don't forget, a negative times a negative will return a positive, so giving us that opposite sign. Okay, so now I have my new points. Here I've labeled them n double prime, y double prime, c double prime, and that is now rotated that 90 degrees counterclockwise. But again, that was fixed around the origin, and so we had subtracted that coordinate to let us rotate using our rule, but now we want to put the triangle back as if it were being rotated around that original focal point, 1, 1. And so if we subtracted it earlier, we will fix that by adding it back at the end. And so now I want to add my point of rotation back to each point, shifting my triangle back up. And so here, -1 plus 1 will give me 0. 1 plus 1 will give me 2. -2 plus 1 will give me -1. 4 plus 1 will give me 5. 2 plus 1 will give me 3. And 4 plus 1 will give me 5. And so here are my final points. And when we graph that triangle, you see that my final solution here in red, and this is my this is my rotated triangle fixed about the point 1, 1. In problem number 10, similar to what we had in problem number 9, I'm still trying to rotate this triangle NUZ, and I want to rotate that 180 degrees counterclockwise, so I want to send it 180 degrees. But again, I'm no longer fixed around the center point 0, 0, right? We're not fixed about the origin. If we take a look into our notation, we see that we're fixed here at the point -1, 2. And so when I go over -1 up 2, this is now the point I want to rotate around, and we're going to use that same method. I'm going to take the coordinates of this point of rotation and subtract it from each of the coordinates n, u, and z. And so when I take a look, here are my coordinates for n, u, and z. Again, n is at -5 up 3, u is at -4 up 5, and z is over 3 up 3. Now, I want to subtract each of those points by -1, 2. Be careful, because we have some double negative situations here. Since our coordinate includes a negative, we got to make sure we still include the negative here. So if I have -5 minus -1, those double negatives will give me a positive, so -5 plus 1 will give me -4. 3 minus 2, no double negatives there, so 3 minus 2 will just give me 1. -4 minus -1, again a double positive, or excuse me, a double negative, giving us a positive, so -4 plus 1 will give us -3. 5 minus 2 will give us +3. Z, here I have -3, 3. I take away -1, giving me back -2. 3 minus 2 will give me back 1. So again, I am subtracting my point of rotation. I'm subtracting those coordinates from each of the vertices to give me my new triangle shifted down closer to the origin. And then from here, I'm going to apply my rule for rotating 180 degrees, since that's what we're trying to do here. Again, that rule is I'm going to multiply not just the front number, but also the back number by a negative. And so I'm going to take each of these points, n prime, u prime, z prime, and I am going to multiply each coordinate by a -1. Essentially, I'm going to just change all the signs for each coordinate. So -4 becomes +4, 1 becomes -1, and so on. -3, 3, 3, -3, -2, 2, 1 to -1. So I apply my 180 degree rule, and that sends my triangle 180 degrees around, fixed around the origin. But again, we weren't originally wanting to fix our rotation around the origin, so we got to go back and add that point back. And when I do so, adding that -1, 2 back to each point, I get the new coordinates, because 4 plus -1 is 3, -1 plus 2 is 1, 3 minus 1 is 2, -3 plus 2 gives me -1, 2 plus -1 gives me 1, -1 plus 2 gives me 1. I plot my final solution, and here in red we have our final image.